Now by now I'm sure that you probably know all of the parts of the atom, but historically we didn't always know that protons, neutrons, and electrons even existed. Today we're going to step back in time and learn about the process it took to theoretically build the atom. The first person to come up with the idea that there are tiny particles in everything around us was a scientist by the name of Democritus. He referred to atoms as atomos or atomos, which to me sounds like a cereal, but it was super important at the time nonetheless. John Dalton, however, was the first person to actually publish a theory on the atom. Thus, we got Dalton's atomic theory. Now, Dalton had four main arguments to his theory. One, each element is made up of tiny particles called atoms. Two, the atoms of a given element are identical. The atoms of different elements are different in some fundamental way. Three, chemical compounds are formed when atoms of different elements combine with each other. A given compound always has the same relative numbers and types of atoms. Four, chemical reactions involve reorganization of the atoms or changes in the way that they are bound together. The atoms themselves are not changed in a chemical reaction. This basically laid the foundation for scientists to build their understanding of the atom. But they began to wonder about its nature. Naturally, experiments ensued to better understand atoms and how they work. The first experiment we're going to talk about was conducted by J.J. Thomson, and he studied electrical charges in partially evacuated tubes called cathode rays. Thomson found that when high voltage was applied to the tube, a ray was produced. Because the ray was produced by the negative end of the tube and was repelled by negative forces, he assumed that the charge of the ray was negative. Thus, the birth of the electron. Now, up until then, scientists were too busy mostly arguing on whether or not atoms even existed, much less trying to determine their composition. So J.J. decided to take his newfound discovery of the electron and put it into a model. This is how we got the Plum pudding model. Because Thomson knew that atoms were electrically neutral, Thomson knew that there had to be a positive charge in order to balance out the negativity of his electrons. His idea was that an atom consisted of a cloud of positive charge with a negative electrons embedded randomly inside of the positive charge. The name was given based off of a favorite English dessert where the electrons are like raisins dispersed in a pudding, or the positive charge. In 1909, a scientist by the name of Robert Millikan furthered Thomson's discovery of determining the charge to mass ratio by calculating the mass of an electron to be 9.11 times 10 to the negative 31 kilograms. Moving forward a bit, in the 19th century, scientists discovered that certain elements give off radiation, thus the discovery of radioactivity. There are three types of radiation that we're going to discuss in this chapter. 1, gamma rays. 2, beta particles. 3, alpha particles. A gamma ray is essentially just high energy light, while a beta particle is an electron moving really fast. An alpha particle, on the other hand, is radiation that consists of a +2 charge. It also has a mass that is 7,300 times that of an electron. One scientist in particular did a lot of research in radiation. His name was Ernest Rutherford. Rutherford decided he wanted to test Thomson's plum pudding model, so he blasted a piece of metal foil with lasers. In all seriousness, his experiment involved directing alpha particles at a thin sheet of metal foil. He thought that the alpha particles would travel through the metal foil without deflecting, but instead many of the particles were deflected at large angles, and some alpha particles even reflected, never actually hitting his detector. Based on his experiment, Rutherford knew that the plum pudding model was wrong. Alpha particles have a positive charge, so there shouldn't be a hard deflection from the foil if the positive charge is spread evenly throughout. There had to be a central clump of positivity causing the alpha particles that got close to deflect, and the alpha particles that reflected were direct hits. Rutherford used his experiment to design a nuclear model of the atom, where the atom has a dense center of positive charge, the nucleus, with electrons moving around the nucleus at a distance that is large relative to the nuclear radius. Now, a lot has happened since these discoveries. And even still, there's more for us to discuss about the atom, but for now, we have a basic understanding of the modern view of atomic structure. The nucleus of the atom contains protons, which have a positive charge equal to the electron's negative charge, and neutrons, which have virtually the same mass as a proton, don't have a charge. Lastly, you need to know that there can be very many variations of one atom. This has nothing to do with the protons or the electrons, but specifically the number of neutrons. These are called isotopes, or elements that have the same number of protons and electrons, but they have different numbers of neutrons. To be clear on what isotope we are discussing, we have a way of writing its symbol. First, you start with the symbol of the element. To the left of the symbol, we include the mass number on top, which is the number of protons plus the number of neutrons, while the atomic number goes on bottom. The atomic number represents the number of protons.